Estimating conversion p-series. The sum of the series S is a sub 1 plus a sub 2 plus a sub 3 plus dot 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 plus a sub n plus a sub n plus 1 plus dot dot dot. There are infinitely many terms. This sum is the sum of the partial sum S sub n, which is the sum of the first n terms, and the remaining terms. The remaining terms is called the remainder R sub n. We will examine the remainder two different ways. If we use the right endpoint for each subinterval of width 1, then the remainder is less than the improper integral from n to infinity of f of x dx. This integral is the area under the curve. If we use the left endpoint, then the remainder is more than the integral from n plus 1 to infinity of f of x dx. We obtain these inequalities because the function f of x is decreasing. Just to be safe, we will use less than or equals and greater than or equals. From the two, the remainder is the actual sum minus the partial sum. We see that the remainder is being squeezed between the two integrals. The integral on the left-hand side is n plus 1 to infinity of f of x dx, and the integral that is more is the integral from n to infinity of f of x dx. Remember that the remainder r of x is unknown, but we know that it is being squeezed between the two integrals. If r sub n equals s minus s sub n, then if we add s sub n to all three parts of the inequality, we end up with the actual sum to be the partial sum, the sum of the first n terms, plus the remainders. Thus, S is R sub n plus S sub n, and that is how we estimate the sum of the conversion p-series. With any approximation, the more terms we use, the better the approximation. To approximate the conversion p-series, we first find the partial sum. This is the sum of the first n terms. We can always compute the sum of a finite number of terms. Then we compute the remainder by evaluating the improper integral. This improper integral will give us a number because we know that the series is convergent. From there, we can estimate the actual sum S.